Here's a video about sets and intersection and union and all these symbols up here on the left. Um, is a subset of is this first one, the complement of, and the universal set, and then intersection and union. So here's three sets. Set A is defined as 1, 3, 5. Set B is defined as 2, 3, 4, and set C is defined as 2, 4. If you had to define the universal set, you could define the universal set from these. Usually, to be honest, you're told what the universal set is, but we can assume the universal set is equal to the set of 1, 2, 3, 4, and 5. Those are all the elements that are in the sets A, B, and C. If we wanted to say, is B a subset of the universal set, we would have to say that that's true. In fact, any set is a subset of the universal set because the universal set has to have all the elements. So that's always true. But take a look at the sets and see if you can see just between A, B, and C if there is a set that is a subset of another set. It looks to me like 2 and 4 in set C is also elements in set B, and B has one other element. So C is a subset of B, but B is not a subset of C. So you can use that same symbol with the line through it, for is not a subset, although I don't think we'll do that much in this book, but I just want to let you know that B is not a subset of C because B actually has more elements in it than C does. So that doesn't work. But C is a subset of B because all the elements that exist in C, the 2 and the 4, are elements that are in B. So that's a little bit about the way the subset symbol works. Now, another symbol we might want to do is we might want to do B complement. So B complement is the set of things that are in the universal set but are not in B. As B is 2, 3, 4, things that would complement 2, 3, 4 to create the universal set are 1 and 5. So and that's another way to think of it. Because B is the set of 2, 3, and 4, it needs 1 and 5 to complement it and create the complete set or the universal set. So that's B complement. That's what the little apostrophe is. So then let's do a little bit of intersection and union. So intersection, this symbol here, intersection, means take things that are in both sets, or that exist, elements that exists in both the sets we are looking at. So if we were to take B intersection C, that would be the things that are in common between the two sets. That'd be 2 and 4. In comparison, B union C, that means take all the elements in B and all the elements in C. We're going to list all of them. We're not going to be exclusive between them. So that would include the 3 also. So 2, 3, 4. Now, what's weird here is that the intersection of B and C also happens to be equal to C. The intersection of B and C, I drew that not very well. Those intersections aren't supposed to have ends on them. The intersection of B and C is also equal to C, and that's because C is a subset of B. Because C is a subset of B, the intersection between them is the smaller of the two sets. So that's kind of a cool thing that's always true. Let's take a look at something maybe a little more complicated. How about the union of A and B? So did that wrong. Where's the back? Huh. Oh, there's the back. There it is. The union of A and B. the union of A and B. Now we want to take things that are in A, all of them, and also all the things that are in B. So we would have a 1, we would have a 2 from B, we would have a 3 from both, we would have a 4 from B, and we would have 5 from A. So there's A union B. It happens to be a universal set in this case, but that's just a coincidence almost. We could also take A union C, and now we would take things that are in both A or in C. So that would be 1, because that's an A. 2 is in C. 3 is in A. 4 is in C. 5 is in A. So we have all those as a union. Happens to be the same set. We can also take B union C. Did that wrong. B union C. B union C are things that are in both B and C. So let's see, we have a 2 from both actually. They don't need to be in both, but we have them in both. We have a 3 from set B. We have a 4, happens to be also from both. So there's B union C. Now you can also do something like you can have parentheses. So let's say we have A intersection the union of B and C. Wrote that out incorrectly. The union of B and C. So you might first want to figure out what is the union of B and C. Well, the union of B and C is 2, 3, 4. 2, 3, 4 elements that are in either one or the other. We're going to take all the elements. We're not going to be fussy when we're taking a union. And then A intersection that, well, A is 1, 3, 5. Intersection means the elements have to be in both A and the set that's the B and C. This should just be a regular round bracket. So A is 1, 3, 5, and this other set is 2, 3, 4. So the only thing in common between those is 3. Okay, I hope that helps with sets.